Find the domain of f of g of x for the given functions. Here we have f of x equals x squared minus 16, g of x equals square root of 16 minus x squared. Now this f of x has no restriction on the domain. The g of x does because it was square root. And so the inside of the square root has to be non-negative. So let's figure out the value that makes inside the radical equal to 0, and then we can go from there. Well, 16 minus x squared, if we have a 4, that would make 0 because 4 squared is 16, and the same thing with negative 4. So basically we want this x squared value to be equal to or less than 16, because if it's greater than, we're going to have an undefined square root in the real numbers. So that means this x squared can be 16 or less, but that means it has to be between 4 and negative 4 for x, because 4 makes 16, negative 4 makes 16, and any number in between will give you a valid solution. So this domain is going to be negative 4 to 4, and it's going to be closed. So why go through all that trouble first? Well, if we're doing a composite function, we want to know the domains of the functions we're dealing with first, and then see how that applies to the composite function. So we're going to do f of g of x. Let's do that. So the g of x will go inside the x here. So f of g of x equals square root of 16 minus x squared, but then that whole thing is squared, and then minus 16. So the squared and the square root, those simplify out, and we have 16 minus x squared minus 16. So these 16s simplify out here, and we just have negative x squared. So we can say f of g of x equals negative x squared. But we have to be careful because the domain restriction applies. Because really, f of g of x in its original form is this guy right here. And we did some simplification, but the domain rules are set right here. So we have the same deal of the square root and the 16 minus x squared, which means this domain right here applies. So even though f of g of x equals negative x squared is the simplified version, the domain is restricted. Okay, so if you were to graph this in its original form, let me show you what that looks like. Okay, so it's going to be open parentheses, square root of 16 minus x squared, and then right arrow to get out of the square root, close parentheses, and that's going to be squared, minus 16. Okay, that's my f of g of x. Just take a minute to look at how it's entered. You have parentheses, and then the square root of 16 minus x squared, and then that whole thing is to the second power, then minus 16. Let's look at the graph. Okay, well, looks like a regular parabola right now, but that's because of the window. I'm going to change the window a little bit. I'm going to go from, say, negative 50 to 50, so we can see more of the y values. Graph that. So now you can see right here the parabola cuts off. And that's what I was talking about with the domain restrictions. Let's look at the table. And you can see what happens. You have valid inputs for integers until you get to 4. And then 5, 6, 7, those are all invalid inputs because you're going to be taking a square root of a negative number. Same thing on the negative side. You're valid till you get to negative 4. After that, errors. Okay? So that really shows you how this domain, negative 4 to 4, really impacts the inverse of the function. So the domain of the g of x turns out to be the domain of the composite function. And there aren't any additional restrictions by f of x, so that's why it's the same as the g of x.